Well, good morning and welcome to Onion Notes. Today's topic, well, it's really about place values and exponents. Really, um, using different bases. We're all familiar with our base 10 numbering system. Remember, we talked about the Hindu Arabic numeral system, base 10. We've got 10 fingers. And now we're going to talk about the base 2 that we all call binary. There's a lot of other bases, but well, these two are very prevalent. Um, we live in the base 10 world, but you know, every one of you got a computer. I guess we work in the base 2 world as well. So a little activity I like to call 2-Bit Tuesday, but regardless of the day of the week, you may find it useful. Um, for any of you that don't know the old reference, 2 bits is a quarter. You have to ask your folks why that is. So enough of that. Let's get to the math. Ready? Let's go. Okay, now this is a pretty boring chart of counting up in binary. 1, 2, from 0, 1, 2, 3, 4. And you could see the pattern given that you only have ones and zeros to work with. But that's a horrible way to try to work it out. There's a much better way. Let's just consider place values like we've done before, right? Now, we know that the place values, well, can be expressed as, well, exponents. Any non-zero number to the 0 power is 1, so that's in our first place. Our 2 to the first power is 2, 2 squared is 4, etc. And the place values would therefore have this value. 1, 2, 4, 8. Keep doubling. 16, 32, 64, 128. What's next? 256, 512, 1024. You probably will memorize the first 10 powers of 2 just because they're ubiquitous in math. Love that word. Okay, let's do some conversions here. We're going to take 1, 0, 1, 1, 1, 0, 0, base 2, convert it to decimal. Ready? First, I'll just put this in these place values. And you say, wait a minute, are you kidding me? It's this easy. How many 64s do I have? 1. I've got no 32s. I've got a 16. I've got an 8. I've got a 4. I've got no 2s and no 1s. So what do? You just add them up. It's that easy. Add up those numbers and you're going to get 92 base 10. Now, keep in mind that, the whole base 10, we leave that off because it's assumed to be base 10, but it's really there because that base could be an 8 there, it could be an octal, it could be a 16, it could be hexadecimal, or it could be, in the case of binary, a 2. So the base is down there. That is a subscript. So we write it that way, right? Okay, let's, I'm going to have to get this guy out of the way because we're going to try some other numbers. Let's try, how do we do this out? Oh, here we go. Let's take this number and put it inside there. And it's the same thing. We're going to add no 64s. Again, the leading 0 could be left off. A 32 and 8. And it's, hey, wait, we could do this in our head. Come on. 32 and 8, that's 40, that's 42. How easy is that? All right, so really just represent it this way. You've got those 3 numbers. Add them together. Hey, you didn't know it was going to be this easy, did you? All right, now let's move on to, let's try another one. So again, I've got my values there. I'm going to combine a 64, and a 32, and a 4 and a 1. Can you do that in your head? Well, yeah, probably. So you got, what, 96 and 4 is 101? Just like those Dalmatians, you got 101. Heavens to Murgatroyds, this is easy. All right, let's just do one more. And this one's just a little bit different because you got all these 1s in there. So let's suppose I put all these 1s in these place values. Now, could do it this way. You could say 64 and 32 and 16 and 8 and 4 and 2 and 1. But if you were on the clever team, you'd say, wait a minute. I know it. I got a secret. That's just one less than the next power of 2. What's the next power of 2? Well, 2 to the 7th power is 128. Double 64, you got 128. So this number, 1111111, must be, 127. It's that easy. All right. Hey, let's try it the other way, shall we? Okay. You talked me into it. Okay. Now, I've got 87 base 10, and we're going to convert it into binary. All right. There's going to be a lot of erase in here. We're going to use these place values. I'm going to say, is there a 64 inside 87? You betcha, as one famous politician once said. Oh wait, I'm going to see how I got this all worked out. So if I were to subtract that, I got 23. Okay. Do I have a 32 in there? No, because 23 is less than 32. But I do have a 16, right? So I got a 16. I'm going to put a 1 in there for the 16. I take away that, I got 7. Now, we could do that little trick we just learned that we know that's going to be 0, 1, 1, 1 because it's, 7 is 1 less than 8. But let's go old school here. Let's just pretend we don't know that. There's not an 8 in there, right? But there is a 4. And I take away that 4 and it leaves me 3. And I take away a 2 and that leaves me with a 1. Heavens to Murgatroyds, look at that. You've got 1, 0, 1, 0, 1, 1, 1, base 2. That's going to be your 87. I hope I've got it written out somewhere. Yeah, do I? Well, let me see. There we go. That's your conversion, base 2. Now let me just get rid of these, get this out of here so we can try another number, because that was so much fun. Whoops, ruh-roh. Well, let's undo that. I guess I meant to do something different. Well, yeah, I guess I messed up making this. So we'll just try another one. So that was 87. How about 54? Let's try this. 54. Well, there's no 64s in there, but there is a 32. So it looks like I'm going to start out like this. That's going to leave me with 22. Is there a 16? 22 is greater than 16. That's going to help me out right there. And that's going to leave me with 6. Now from here, we say, wait a minute, we can do this ourselves because we can see 6 is 4 plus 2. And for a placeholder, a 0. Well, there you go. So how did I do that? Okay, I've got that. And well, hang on. Yeah, that's 54. Make sure I got it in the right place. Can we do 111? Heck yeah. I guess I'm going to have to get rid of these. Let's get rid of all that. And let's try 111. I know I've got a 64 in there. And I'm left with 47. 47 is bigger than 32. We like where this is going. And then it's 15. So you know what's going on there. That's not 16, but I know it's going to be every one thereafter. And again, if I wanted to see it done out, I've got an 8, right? If I've got an 8, and then I've got 7 left over. The 7 contains a 4, which is made up of a 4 and a 2 and a 1. So there is your number 111 in binary. So let's see, do I have it set up? There it is. Glad I got that worked out. Okay, we're almost done. We're almost done here. We're just going to finish up the last two really quick. Oh heck, the last two we could do really easy. And I'll just leave these on the place value marker here. Get rid of these. 96, 64, and 32. That's 96. You're done. And we need to put in the placeholders. We've got 0, 0, 0, 0, and 0. That is the number 96 in binary. Remember, when you are writing the binary, to include the 2 in the subscript. And let's see, what else we got there? Yeah. And then we'll check out 73. Oh, dang it, I don't think I've got that one done, but that's no need to fear. We can bang that one out really quick. You've got 64, right? Yep. And when you take 64 away from 73, you got 9. Oh, heck. And 9 is 8 and 1. All right? So 64 plus 8 and 1 makes 73. And how do you indicate the place values? Yes, our good friend 0 to hold those places. And there you go. There is the number 73 in binary. And we'll call that quits for the day. And maybe you can find this worksheet on 90 Notes site, or just have some fun and talk about it with your teacher, and just keep enjoying math. And everybody, as always, thank you for watching 90 Notes.